Hello everyone, my name is Cansu Tümer. I'm a freshman student in Bilkent University in Industrial Engineering Department. Today I'm going to present to you my Physics 101 lab project. My experiment is about investigating energy loss when a spring is compressed with a puck on an air table. In the experiment, the required materials are air table with low friction pucks, a spring, a carbon paper, a ruler, a scale, and a known mass. Firstly, I measured the length of the spring by using a ruler on its initial position. And then I hung a known mass which was 40 grams, and I measured the length of the spring by using a ruler on its final position. Then I attached the spring to the corner of the air table and compressed it using the puck. Then I measured the distance of the compression to later use it to find the potential energy that was stored in the spring. Then I released the puck while the air pump and spark timer of the air table was activated. Then I measured the distances between the dots that was made by the spark timer in every 100 milliseconds. Then I used these distances to calculate the initial velocity and the final velocity of the puck. I found the average initial velocity as 0.26 meters per second and the average final velocity as 0.21 meters per second. So when I calculated the initial velocity and the final velocity of the puck, I calculated the potential energy that was stored in the spring initially, and then I found the initial kinetic energy of the puck when it was released, and I found the final kinetic energy of the puck. Then I calculated the energy loss by subtracting the final energy from the potential energy that was stored in the spring initially. So in conclusion, I found the energy loss 35.6%. This energy loss that I found was probably because of the friction. The air friction, and even though the air table is supposed to be frictionless, it has some friction on it. And additionally, there may have been some measurement errors, such as inaccuracies in determining the spring compression or the puck's velocity. For future improvements, we could use more precise tools for measuring the spring's compression and the puck's velocity, and we could use a higher quality air table, or we could vacuum the environment to eliminate air resistance. Overall, this experiment demonstrated how energy conservation is affected by the real-world conditions, such as friction. These results were aligned with the expectation of energy loss due to the real-world conditions. Thank you for listening to me.